I always object to hype in science because it always comes back and bites you in the butt. When scientists claim things that aren't the case, they're laid to be proved wrong. The hype about quantum gravity being a theory of everything, even if it were true, it's probably a theory of very little. Namely, it's a theory of the beginning of the universe and the center of black holes. But you don't have to know anything about quantum gravity to figure out how oatmeal bowls or to build your detectors for that matter.
After the first time you were on the podcast, we've known each other for 32 years. But
really? Well, you were just a little
I was a wee lad.
You were just a little bit of noise in my life back then.
I'm quite noisy. By the way, do you know where the word, since you're an erudite Renaissance man, do you know where the word noise comes from, what its etymology is?
Of noise?
Yes.
No, I know some languages, but I know in French it's police, so it doesn't come from that. It's not got it isn't from Latin. So
it is from Latin. So it means nausea. It's related to the root word nausea. So now you know what we feel when we experimentalists encounter noise and what you felt when you first met me. Okay, Lawrence, here we go. This was a comment that I got after your first appearance.
Amusement more than nausea. Go on.
You write very beautifully, as usual. I enjoy reading your books, even when they depress me and cause me to go to the Prozac, Xanax, and Viagra bin all at the same time, Lawrence. But you write beautifully. You say, science works because it changes its mind. Here's a mind that my son made in honor of this podcast. Nice. So it's about life.
Does he have a 3D printer? Is that or no?
No, this is from our cat. As people like the late, great Sir Arthur C. Clarke, namesake of this podcast, if you will, he once said that if I'm not calling you elderly, but if a wise older scientist says something is impossible, he is most likely to be correct. Or she. But if she says something is impossible, she's very much likely to be wrong. And I want to ask you, what belief of yours has data forced you to abandon, if anything?
Well, first of all, belief implies faith in something without evidence. And science things are likely or unlikely. You know, almost every day I change my mind. But of course, the biggest one was ultimately changing my mind about the energy of empty space. I'd grown up with a rational argument that the energy of empty space had to be zero. From a fundamental theoretical perspective, it's the only sensible value that it could have. And I was driven kicking and screaming. It took me 2 years to write that paper, which I wrote with Mike Turner, because it looked like it must be there, but it just didn't seem like it was so heretical that I had to convince myself on the basis of data. That's one example. The other, so obviously that's one that is self-serving, because I'm very proud to have been one of the first people to argue that empty space had energy. But I'll give you another example. I was convinced that the Higgs boson didn't exist. It just seemed like it was too simple and smarmy a solution to a fundamental problem in elementary particle physics. In fact, I got my job at Harvard the first time, I remember in the interview saying I was working on an alternative to that because I just didn't believe and I used the word believe probably, because it just seemed too simple, too facile a way to solve a deep problem in fundamental particle physics, the spontaneous breaking of gauge symmetries, which is so fundamental to everything about our universe.
What do you make of DESI? What do you make of these recent results?
Much ado about nothing, in my opinion. The dark energy is constant. I'm not convinced of any.
They claim 4.2 sigma, 1 in 36.
Yeah, I know. But I'm older than you. I've seen 4.2 sigma come and go, especially when sigma doesn't mean anything in astrophysics so much. It means something. But systematics are much more important than statistics when it comes to the edge of evidence, as you know well from BICEP.
I do know well. And you were a big part of it. You're page 132 of my first book.
I think it's really important to know that, but I guess I just have to be, again, it's a question of what's likely and unlikely. Based on everything I know about the world's data and the difficulty of doing what they're doing and the theoretical perspective, I think it's much more likely that dark energy will be indistinguishable from a cosmological constant. And I have a big bet on that, which the other people on the bet now will refuse to ever admit that they bet. One of them is dead, Stephen Hawking. The other is Frank Wilczek, and he'll never agree that he bet the other side of it. Anyway.
Well, Stephen Hawking was the most. I want to get into some serious fun speculation. I saw this paper, quantum gravity cannot be both consistent and complete. And I immediately thought of this paper by Gödel on the completeness of mathematics, which then has relevance to both artificial intelligence and, if you'll permit me eventually, to aliens and the Drake equation, but we'll hold off on that for now. But quantum gravity, is this deliberately related? There is a section on the quantum version of Gödel's incompleteness theorem. So let's take a giant step back. You haven't written many papers lately, so when you write a paper, people, ears perk up, and that's originally why I wanted to.
Not from my experience, but anyway, go on.
What does this mean? Quantum gravity. First of all, my friend Eric Weinstein says that quantum gravity is a mental disorder, that you guys are just fighting the last war. You guys are just wannabe Einsteins, not Weinsteins. And you literally are just, kind of trotting over this. And I only agree with him on the following contention, Lawrence, is that quantum gravity as a theory of everything is kind of putting the toe before the gut. We don't have a grand unified theory, correct?
No.
So how can it be that quantum gravity could be a theory of everything and bypass the gut unification?
Well, the argument was, I'll take you back in history, and statements of Eric Weinstein notwithstanding, I'd rather talk about data and real physics. What seemed exciting in the early days of string theory was that it looked like a gut might come naturally out of string theory. That in order to compactify certain dimensions, so you had a large four-dimensional universe, there might be only certain gauge groups that are allowed to be to exist at low energies. And the idea was that to understand quantum gravity, one of the beautiful byproducts would be that it would point uniquely to a theory of the other three forces in nature, or four or five if there were more. The early people in 1984 were pretty convinced that was going to be the case. That was the reason they started to call it the theory of everything. And I do like to constantly give my friend Frank Wilczek credit for this, because he's always said that he didn't want a theory of everything, he just wanted a theory of something. And so I objected to that at the time. I always object to hype in science, because it always comes back and bites you in the butt. When scientists claim, whether it's COVID or whether it's string theory, claim things that aren't the case, that are laid to be proved wrong, the public's trust in science diminishes. So the hype about quantum gravity being a theory of everything, when it's actually even if it were true, it's probably a theory of very little. It's a theory of the beginning of the universe and the center of black holes. But you don't have to know anything about quantum gravity to figure out how oatmeal balls or to build your detectors, for that matter. But by theory of everything, what one means is a fundamental mathematical, at least in my opinion, a mathematical, well-defined mathematical theory that explains all experiments you can do and all experiments you could ever do. And I was motivated, by my colleagues, somewhat kicking and screaming, to write that paper that you were referring to point out that fundamentally, since physical theories are mathematical, and there are mathematical incompleteness theorems, that there are limits to what you can know to be true on the basis of the mathematics of the theory. And that I would interpret that to be, there are experimental results that are true that you might not be able to prove are true within the context of the theory. Moreover, there are certain areas of physics which we know are undecidable. There's a famous undecidability theorem in computers about when a computer that builds itself, when it turns off, when it can, based on the program, when it's controlled. And that's been shown to be equivalent to the question of of how a system thermalizes. Thermalization is a very complicated process. People have killed themselves in physics history, trying to understand physical mechanics and thermal physics. And so there could be processes where you fundamentally need to do the experiments, and the theory might not be able to tell you what the answer is going to be in advance. And so this is a rather formal paper that uses Gödel's and a bunch of other undecidability theorems to point out that the claim that you have a mathematical theory that really is a theory of everything is probably ill-founded. And it's an interesting point. I'm happy people perked up, and I know there was a lot of tension. I don't think it's that important, personally. I don't think it's going to stop people from going ahead and... It's like a lot of mathematical physics. I mean, we can't prove a lot of things about fundamental physics, but it doesn't stop us from, going ahead and doing things. We can't prove, much of quantum. There are people who want to do these absolute mathematically rigorous proofs in quantum field theory, and they spend their whole lives doing it. But, you can just do Feynman diagrams and make predictions about G minus 2 of the muon and get it to 13 decimal places. And so I prefer to just go ahead and do things and try and make predictions that you compare with experiments. And these grand things are sometimes a little, every now and then I succumb to grand statements, but I try not to, especially
you grandiose, never, my friend.
I try not to be grandiose. I try to provoke, but I try not to be, there are some things I've done that have an impact that are very theoretical and not related to experiment, or at least their Gedanken experiments. But on the whole, I haven't done that a lot.
I'm seeing a lot more attribution to you for things like dark energy and you and Mike Turner than I've ever seen before. I think there is some sort of, Krauss. It's all coming up Krauss.
It's a little too late for the Nobel Committee, though. But anyway, that's all right.
Well, you know how I feel about that.
Yeah, I know. I don't care.
Let's not get
Anyway,
into that.
you're obsessed with Nobel Prizes. I try not to
For a
be.
different reason, yes.
Anyway.
Exactly. I want to reform. I'm like Jeremiah in the Bible.
I don't think prizes are worth reforming. The prizes are arbitrary. It doesn't matter. Anyway, go on.
I'd like to mention one thing. I mean, you wrote this as part of a Gravity Prize essay. You did win a wonderful Gravity Prize essay with Frank a long time ago.
I've won it twice, by the way.
Twice. Okay,
twice. I always wanted to do because Stephen Hawking won it twice, and I wanted to win it twice. But anyway,
now maybe you'll be in the trifecta. Do something he never did.
I was hoping to win it 3 times. But yeah, anyway.
So there's something in here which I didn't know about. I've talked with Roger about this, but the Lucas-Penrose argument says that human insight can see truths that no algorithm can, hinting that pure computation can't capture all of physical reality. Now we're getting into the brain here. I've never asked you about your theory or your thoughts on fellow Arizonan, or at least, a different part of Arizona.
I have co-authors. I wouldn't have included it if it were up to me. Look, my last book, the one before this, The Edge of Knowledge, which I'm sure we talked about, I talked about consciousness in the last chapter. And I pointed out we don't have the slightest understanding of what consciousness is. So when people make claims, including Roger Penrose or his other less distinguished colleagues, about how the brain works and what consciousness is and what it can and can't do, I just turn off and listen to music or something.
The only thing I want to mention about that is sort of the sunk cost fallacy, and I'll ask 2 questions about sunk cost, and then we'll wrap up, and you can get to your ice fishing or whatever you do up there. The sunk cost of quantum gravity, in my opinion, might stem from these 2 potentially, or maybe not even potentially, but factually unobservable objects in the universe or events. One's an object, one's an event, and that's a singularity in a black hole, and the other is a singularity potentially in the origin of the universe, the Big Bang, if indeed you conflate the Big Bang with the origin of time, which we can debate. But since those are the only 2 things out of a near infinitude of possible things that we could study in space or time or objectively, why do we give so much attention to these 2 objects? Why is quantum gravity a thing that has decades and hundreds of...
It's sociological, right? People there's a fascinating mathematical basis, and people get sucked into that with the hope that they'll be able to do something wonderful. So I think people get sucked into the mathematics, and that's understandable because a lot of good things have come out of those mathematics that have nothing to do with quantum gravity. But I think to say that it's not important to know how the universe, to be able to answer the question possibly how the universe originated, is to say that all the work you and I do in cosmology is unimportant, because what the hell does it matter, what happened in the early, because ultimately we want to know our origins. That's one of the reasons I call the Origins Project, because origins and frontiers are intimately tied. And I think humans are always going to ask the question, how did it begin, or was it always here? And the fact that science might be able to address it is amazing. And again, black holes are just sexy objects that defy logic, apparently. And so are they regions where the laws of physics end? Well, that's a fascinating idea, and it's tempting, and I have no problem with people working on it. I think most of what's being done is probably, in the long run, going to be, used later on to fill landfills. I've thought about it, and I've written about it, and every now and then. And I think, once again, you have to choose smart people and let them do what interests them. And some of it will be useless and some of it will be useful, and you don't know in advance what.
The last question before we wrap up, Lawrence, has to do with sunk cost, and it's something called lock-in. If you might be familiar with this, you might not be. Stop me if you've heard this one before, but the Hubble Deep Field was only made possible because of the width of a horse's ass. Have you ever heard this before, Lawrence?
I'm biting my tongue, Brian, but no. Yes, go on.
You're about to hear from another horse's ass.
No, things I could have said, but I didn't.
I know you, Lawrence.
Anyway,
too well.
Okay.
So the space shuttle needed to launch the Hubble telescope and to repair it later on, a couple of years later, as you know. Its altitude was determined by the solid rocket boosters that lifted it into orbit. Those solid rocket boosters were built here in Utah, or in the western U.S., and they had to be shipped to the East Coast, to Cape Canaveral and in Florida. And to do so, they had to go through like 10 train tunnels. vehicles.
On the train, the famous width of trains. Yes, okay.
The width of trains. So the width of a train track is set by the width of a Roman chariot,
Yeah.
which was set by the width of two horses' asses. Okay,
Yeah,
so
okay.
now you can insert a joke about both of us.
Yeah,
if
I
you like.
kind of figured you were going there, but okay.
So that determined the altitude that the shuttle got to, which is not optimal, right? It's in the magnetic field of the Earth. It gets a charged particle. It can only observe 90 minutes at a time before it gets irradiated. Anyway, a whole bunch of reasons it was suboptimal. I'm asking the following question to you. Are we getting locked in to AI that will fundamentally prevent us, because of its success, because of the lock-in phenomenon of GPUs plus LLMs, that we're going to never get to advanced new laws of physics, which I think is I call it the Keating test. Can an AI system come up with a true new law of physics that's verifiable empirically so? You may have a different definition, but mine is that, and I don't think we're anywhere near it. I've even tried to get it to derive the perihelion of Mercury just from data that I supplied from JPL Horizons for 2,000 years.
There's a lot of hype. AI has a lot of hype. That's one of the reasons we talk about it a lot, because I try and attack the hype. And Elon Musk is Mr. Hype.
Are we dooming ourselves to, or do you think there'll be some...
I can't, I've said this probably to you before, but I don't make predictions of the future unless it's 2 trillion years in the future. And I can argue strongly that I think I know what's going to happen. And moreover, you won't be around to test it, so it doesn't matter. Things are changing and governed by the laws of the market and also the predilections of certain super rich individuals. And it's a lot of hype, but it is also potentially incredibly useful. And I think it's premature to argue for the death of physics. The kind of thing that's important to physics is not to answer questions, but know how to ask them. And AI is pretty good at answering questions. A lot of times it's wrong. By the way, I should say I'm a dinosaur. I don't use AI. A lot of people
You don't use it?
No, I don't use it at all. I guess my implicit lack of trust. I'd rather do the research myself and check it. It's just predilection. I realize that, I probably miss out on some things, but Feynman Feynman missed out on a lot because he should have realized other people derive things that he could derive himself. I'm not that, but I tend to not use those things. I've used them once or twice because I like researching and I like doing it. And it's but I've seen when I have used it, I've become suspicious. When ChatGPT first came out, I wrote a piece. I asked it about gender. And I saw that what it gave me were the arguments of the people who trained it. And so it immediately caused my suspicions. This is my big issue about AI in the long run. I suspect AI will become much better at diagnosis, if it isn't already, than doctors. But will you be willing? Here's the key question. Will people be willing to say, okay, the AI says do this. Put a paper bag over your head and scream like a chicken. And without any relationship to the underlying biochemistry or molecular biology, say that this treatment is likely to work. Will people be willing to take that black box and do it? It'll be an interesting question.
They already do that on TikTok.
I think claims about AI in general I take all claims about AI, including the one you just made, with a grain of salt. It's evolving. It's useful. It's not, I don't even think it's either artificial or intelligent. So there you go. But I do think in the long run, not now, but in the long run, it's quite likely that the surviving intelligence on this planet won't be carbon-based. More importantly, for those people who like to think of aliens and sending people into space is always stupid, except it's for adventure. If any long-term memory of our existence in the cosmos is going to be preserved out in space, it's not going to be humans that'll be preserving it.
All right, Lawrence, we have a tradition on this podcast, the final question to an author, a brilliant mind such as yourself. I think I've never asked you this version of it, but the title of this podcast, Into the Impossible, comes from Sir Arthur C. Clarke's statement that the only way to know the limits of the possible is to venture beyond them into the impossible. And did you know that podcast comes from 2001: A Space Odyssey?
That, you mean not the podcast, you mean the quote?
Well, no, that the word podcast is directly related.
2001. I have to say, I love 2001. I sometimes think Arthur C. Clarke is given too much credit for his statements. But anyway, go on.
This was Steve Jobs as well. So this engineer at Apple who invented the iPod told it to Steve Jobs that he thought it looked like the pod of the Pod Bay Doors fame, behind my head.
Oh, yeah, Dave.
But anyway, Arthur said the following about the Into the Impossible, that you have to transcend the limits. I want to ask you, as a callback to the book, The War on Science, if you could go back to a 25-year-old Lawrence Krauss and tell him, in 25 seconds or less, what he should do with his life, because of what you've seen, would you advise them, would you basically say silent, or would you say avoid academia? In other words, has it really transcended, what you or I could have possibly, feared 25 years ago or when you were a kid? What would you tell yourself, if anything? Or would you stay the course and say nothing at all?
Well, I would tell, first of all, don't let the bastards get you down, and do what interests you. And that's it. If you're not doing what interests you, you won't do it well. Don't second guess the future. Just keep doing it and keep doing it and keep doing it. And, and there's another quote I love by Winston Churchill, which is never, ever give up. So those are the advice I'd give him. And that's none of it. Most of it's not from me. One of the things I did learn, I was a mathematical physicist originally. And then my mentor at the time, Sheldon Glashow, said to me, you know what? You have to know the difference between formalism and physics. And there's an important difference. And I changed so that most of the work I do, not all of it, has always been closely related to experiment. Something you can actually test. Now, it's not all there, because sometimes I'm trying to think way beyond what experimentalists can do. The Higgs, I kept my nose to the ground, or my ear to the ground, I guess is the right way to say it. And so I was quite aware of, as they were narrowing the gap where the Higgs could be. And I remember I was in Australia, because I used to travel back and forth, and talk to some people who were working at the LHC. And they said, I remember hearing in May of that year, we've ruled out the Higgs in this entire mass range, except for this little range. And we're going to rule that out in the next month. And of course, the Higgs ended up being in that range. And, so that was, but of course it's there. But I remember I much preferred it not to be there. And it was a good example of the fact the universe doesn't care what I like or don't like. I'd much prefer dark energy to be zero, frankly. It makes the world simpler. But in fact, actually, it makes it more interesting because it means we don't understand something fundamental.